Good evening. Today's quote is you miss 100% of the shots you don't take. You miss 100% of the shots you don't take. Today's word is epoch, an event or a time marked by an event that begins a new period or development, a memorable event or date. After the completion of sets and relations, we start a very important topic, functions. In calculus, without function, it cannot be, rather we cannot function properly. So you should know definition of function, you should know different types of functions, and we can study functions after discussing relations only. After all, function is a special type of relation. Here I have showed four relations. I haven't named them. You can say that A is the first set, B is the second set. In all the four cases, you will appreciate that in each case the sets are related. That is, there exists a relation from set A to set B. Now, out of these four relations, first one is not a function. Second one is not a function. Third one is a function, means this one, see the arrow. And fourth one is also a function. Now, can you tell me the criterion? Okay, I'll tell you the answer. See, for a relation to be a function, relation from A to B, every element of the set A must be uniquely associated with an element of the set B. Now see the cursor. First relation is not a function because every element of A is not uniquely associated. Second is not a function because A has no unique association. A is associated with more than one element. In the third case, you may take objection that A and B have the same association. See, the definition says each element of the set A must be uniquely associated. Tell me whether A is associated with more than one element. No. B, no. C, it is also uniquely associated. And therefore, in the third case, relation is a function. Now, in the fourth case also, every element is uniquely associated with an element of the second set. And therefore, it is also a function. Okay? Yes. Now, what is the definition of function then? Let me define that. Let A and B be two non-empty sets. Listen to me carefully. This definition is very, very important. Let A and B be two non-empty sets. If every element of the set A, is related to one and only one, that is unique element of the set B, then such a relation is called a function from the set A to the set B. See, this is set A, this is set B. Relation is a function. Here I write ABC, PQRS. Yes, you will notice that every element of the set A is uniquely associated with an element of the set B. Now don't say that, but sir, S has no association. Nothing is mentioned about that. You have to see whether, because we say that relation is from A to B, right? So you have to just see whether each element of the set A is uniquely associated or not. Yes, it is, right? So this relation is nothing but a function. Now functions are denoted by FGH, either small or capital. If F is a function from a set A to a set B, then we write this as, see, F is a function from set A to set B, or like this. f is a function from A to B. Okay. The set A is called the domain. We have already used these terms in case of relation. So set A is called as domain and set B is called as codomain of the function f. Now, if x belongs to A, then by the function f, x is related to one and only one element of the set B. Let this element in B be y. So I'm saying this is x. Oh, this is x and this is y. Okay. We write this as f from x to y. Okay. The element y is called the value of the function f at x. See, this term is very, very important. Or in general, I can say, what is p? P is called as value of the function f at which point of the domain? At A. What is q? Value of the function f at which point of the domain? B. What is R? It is value of the function f at C. In general, y is known as value of the function f at which point of the domain? X. And that is why we always say y equal to fx, y equal to fx is the function. I hope this is clear to you. P is called as image. We have already used this word in relations. P is image of A under F. A is pre-image. B is pre-image of Q. C is pre-image of R. So clearly, set of all images is nothing but the domain of the relation. Will you say set of set of all pre-images is the domain? Will you say set of all images is the codomain? That is set B? No, because you will notice that here S is not the image of any of the element. So you have to say that set of all images is the range of the function. And you can add to it that range is a subset of set B, that is subset of codomain. I hope this is clear to you. Okay, so this is nothing but the concept of function. Now there are different types of functions. Or before that, let me ask you, so that will give me an idea whether you have understood the concept or not. Okay, shall I repeat this once again? Okay, I'll do that. Just listen to me carefully. Let A and B be two non-empty sets. If every element of the set A is related to one and only one, that is unique element of the set B, then such a relation is called a function from the set A to set B. Functions are denoted by letters FGH, either small or capital, right? So if a function f exists from set A to set B, then we write this as f from A to B. The set A is called as domain of the function and set B is called as codomain of the function. Here we say that P is the image of A under F. A is the pre-image of P under F. Set of all images is called as range of the function, which is a subset of codomain. P is called as, see, according to me, this is the most important concept. P is called as value of the function f at A. In general, an element of the domain is denoted by x. It is called as independent variable. And its image, which depends on x, is dependent variable. So y depends on x. Y is called as the image of x under f. Y is also value of the function f at x, and we write this as y equal to f of x. Now we discuss types of functions. The first one is known as 1-1 function. It is also called as injective function. Now see, A, B, C, PQRS. Now this function is called as 1-1 function. Okay, this is A, this is B. So f is a function from A to B. Now how 1-1 function is defined? A function f from A to B is called 1-1 function if every image in B does not have more than one pre-image in A. I repeat, every image in B does not have more than one pre-image in A. In simple words, no two elements in the set A should have the same image. So in that case, it will not be 1-1. More than one is called as many. So if A and B have the same image, it is allowed in a function. Still, it is a function, but it is not 1-1 in that case. Okay, I hope you are getting this. It is called as injective. Now, second important definition is onto. See, you have to remember these words. Onto function, which is also called as surjective function. I hope you will be able to tell me the difference. I will be writing two functions. The first one will be onto, second one will not be onto. Now try to tell me the difference. ABC, PQR, ABC, PQRS. Clearly, both the functions are 1-1, but the first one is onto, and the second one is not onto. So how will you define onto function? Yes. See, a function f from A to B is called onto function if range of the function is codomain itself. Okay, it is better if I name this so that I can say that the range is codomain B. Here C, D and function G. So both f and g are functions and clearly they are 1-1 functions. But function f is onto and function g is not onto. Why? Because in case of onto function, the range is codomain itself. Can I say in case of function g that range is codomain? No, range is a proper subset of codomain D. The element S is not at all associated. Okay, so this is the definition of which function onto, that is surjective function. I think a good student will definitely remember this. In case of this 1-1 onto function, a function can exist from set B to set A. In 12th standard, we are going to call it as inverse function. See, if you try to obtain a function from B to A, it is possible in case of f, but it is not possible in case of g. Okay, so if the function is 1-1 and onto, then in that case, function from B to A also exists, and we are going to call it as an inverse function. We are not interested in discussing that at present. The third one is many-one function. You have to take literal meaning. A, B. So A, B, C, D, P, Q, R. So A associated with P, C associated with P, B associated with R, and D associated with Q. So you will notice that the elements, rather two elements, here you will notice that many elements associated with one. A and C. A and C are associated with single element. So it is many-one function. See, if you want to write, you can, but I'm going to upload PDF file. See, I will upload two files, one for theory part and other for homework. But if you want to write, you can. Now, this is about many one function. One student is asking, can many one function be onto? Yes, in fact, this is the example of many one onto function. See, what is the criterion for onto function? Range must be equal to codomain. Yes, codomain B itself is range. So this is onto. But this is many one. I hope this is clear to you. Now, another type is into function. Simple one. You can also tell me the definition of into. One which is not onto is into. See, f is a function from set A to set B. Because this is set A, this is set B. You will notice that there exists at least one element in codomain which is not the image of any of the elements. So such a function is called as into, I-N-T-O, into function. So how will you define an into function? Simple. The range is proper subset of codomain. So in that case, function is into. Now this is nothing but one into function. I can make this as many one into function. Why many one? Many associated with one. And why into? Because the element S, there exists at least one element in the codomain which is not the image, or there exists at least one element which has no pre-image in the domain. So this is not at all difficult. Now, this cannot be a function. I'll give one example. A, B, C, P, Q, R. Can this be a function? No. Why? Because one many, in fact, one associated with many, many associated with one. So this is many. We have seen that many one is a function, but one many can never be a function, because what is the criterion? Every element should be uniquely associated. Here A is not uniquely associated. Okay, so this cannot be the function. I hope this is clear to you. Now the next simple part, this is not at all difficult, is a representation of a function. If you ask me, the simplest method is arrow diagram, which I have just explained. This is the simplest method to represent a function. That clearly gives an idea about the domain, codomain, and range of the function. Then function as a rule. One, two, three, 1, 8, 27, 31. A to B, function f exists. Now here, the function f can be represented or can be defined by a rule. It is cube of. Is cube of. For example, 1 is cube of 1. 8 is cube of 2. 27 is cube of 3. That's it. Okay. So this is the second method, rule method. The third method can be formula method. So I can say that y equal to f of x. Every time you have to write function as y equal to f of x equal to x cube. See, an element of the domain is denoted by x and the corresponding image value is denoted by y. So how y is obtained from x? On cubing x. So y equal to f of x equal to x cube. This is the third method of representation of a set. This is called as formula or equation. Then function can be expressed as set of ordered pair. Set of ordered pair. So here I can say that f 1 1 2 8 3 27. The drawback of this method is, in case of arrow diagram, we can see this element 31, which is not seen in this case when we express function as a set of ordered pairs. And the last method is tabular form. In some cases, we express the function in the form of table. First row headed by x, second y, that is f of x. So f of x is value of the function at x. Now here I will say x 1 2 3, corresponding values of the function 1 8 27. Again 31 has no place here. Okay, now we are mainly interested in 12th standard, in 11th standard and 12th standard also, in real valued functions. What is the meaning of a real valued function? A function whose codomain is the set of real numbers. That is, set of real numbers capital R is called as real valued functions. Now, after this, in the textbook, they have given graphs of functions, then different types of functions, but we will not discuss that part right now. Instead, we will solve few examples from the first exercise. Now exercise 6.1, check if the following relations are functions. A. Actually, you are not supposed to write just yes. You have to write the reason for that. You are supposed to say that it is a function because every element of the set A is uniquely associated with an element of the set B. Now, in the second case, it is not a function. Why? Because the element, I think, R is that element? Yes, because an element R belonging to set A is related to two elements. So one many relation can never be a function. In the third case, it is not a function because every element is not uniquely associated. So -2 has no association. I hope this is clear to you. So this is first question. Second, which sets of the ordered pairs represent functions from A to B? Justify. Now, I will not write that relation, but in A they say 1 0 3 3. See in the textbook, 2 minus 1 4 1 2 2. Is it a function? No. No. R is not a function. Reason? What is the reason? 2 belonging to A is related to two elements. So one many cannot be a function. See, if your concepts are clear, you won't find this difficult. What about B? 1 2 2 minus 1 3 1 4 3. See, you have to be very careful. Each rather the first elements should belong to A strictly, and second elements should belong to set B. Don't just observe that each element is uniquely associated. Basically, the first element should be from domain set A. You have to be very careful. And second element in the ordered pair should be from codomain set B. Yes, 1 2 3 4. Then 2 minus 1 1 3. Yes, all of them belong to codomain. So R is a function. And here you have to mention the reason that every element is uniquely associated. That is very important. Now, what about third? R is not a function. What is the reason for that? Yes, for third, see, 3 belongs to A and has no association, or I can just say has no image, if you want to write this in short. And D, 1 1 2 1 3 1 4 1, is it a function? Yes, f is a function. Now don't say that all of them have the same image. Nothing is mentioned about that. Every element should be uniquely associated. Now, two or more than two elements can have the same association. No objection in that. Okay. So R is a function. R stands for relation. See, every function is a relation, but every relation is not a function. So here I say R is a function. And you have to mention the reason also. Below this, you have to say that every element of A is uniquely associated, and that is why it is a function. Now, third sum, check if the relation given by the equation represents y as a function of x. See, this is important. First is 2x plus 3y equal to 12. See, you should know that function, if it exists, can be represented by y equal to. So try to write the given relation as y equal to 2x plus 3y equal to 12. So y is what? 12 minus 2x upon 3. Now, how this is inverted A. How to read this? For every x which is a real number, we can find unique value of y. And therefore, y is a function of x. Okay. So this is how you have to present. Then B part, x plus y square equal to 9. Okay. So y square is 9 minus x. So y is plus minus root of 9 minus x. In fact, we cannot assign any real value to x. X has to be less than or equal to 9. Okay. But if we say take x equal to 0, then also we get two values, right? Therefore, R is one many. Therefore, it is not a function. Are you getting this? For one value of x, we are getting two values. So this is second. Now, third part, x square minus y is what? 25. Okay. So what is y? Y is nothing but x square minus 25. For every x, we get unique y. So relation is a function. Okay. Now what can you say about D and E? What is D? 2y plus 10 equal to 0. So y equal to minus 5. Now you may say that this is not a function because x is not there. I can, just a minute, I can write this as minus 5 into x raised to 0. Assign any real value to x, right? So R is a function. We are going to call it as constant function. Assign any real value to x, its image is always -5. 3x minus 6 equal to 21. No y is involved. Therefore, it is not a function. It is not a function. Okay. This is not difficult. Now, sum number 4. See, this concept is very important. Value of a function at a point. F of m is m square minus 3m plus 1. See, we are going to discuss that this is a polynomial function and it is always defined. You can assign any real value to m. It exists. Okay. Now, what is asked? F of 0. You have to use common sense. You have to replace every m by 0. So previously it was square of m. Now it is square of 0. Previously it was minus 3 times m. Now our aim is to find f of 0. So replace every m by 0. Okay. Plus 1 as it is. Now you will ask me why not to write 0 here. See, replace every m by 0. Can you see m here? No, it is 1 constant. So as it is. That is why f of 0 is 1. What is f of minus 3? Minus 3 square. Don't write minus 9 plus 9. Minus 3 into minus 3. That is plus 9 plus 1 as it is. So 19. Can you tell me what is f of half? Half square, that is 1 by 4. Then 1 by 4 minus 3 by 2 plus 1. So I think it is, just check this, minus 1 by 4. Yes or no? Yes. So what is D? F of x plus 1. You have to be very careful and you have to use common sense. Previously it was m square. Now square of x plus 1. Previously it was minus 3 times m. Now many students do not use the bracket and then say this topic is difficult. See, basic things you should know. That how can you say minus 3x plus 1? M is to be replaced by x plus 1. So strictly you have to put x plus 1 in bracket. Now tell me what is x plus 1 ka square? X square plus 2x plus 1, open the bracket. So minus 3x, don't say plus 3, minus 3 plus 1 as it is. So on simplification you get what? You get x square, then minus x minus 1. This is what? F of x plus 1. Right on? Now one student is asking, are we supposed to find the roots of an equation? Please, this is not an equation. This is an expression. See, m square minus 3m plus 1. Are we given that it is 0 or something? No. So why are you saying, are we supposed to find the roots? This is not an equation. This is the given relation. That's it. Then E part, f of minus x. This is interesting. So square of minus x. Then minus 3 times, put minus x in bracket, plus 1. I hope you understand the difference between expression and equation. See, f of x is x square plus 3x plus 1. There is no point in finding the roots. You can use the word factors. Don't say roots. But we are not asked to find the factors. Now, F part is interesting. Of course, you have to find these separately. In F, you are asked to find what? F of 2 plus h minus f of 2 upon 3. I hope you will not say, see, I have seen students writing f of 2 plus h minus f2. They say fh remains. This is ridiculous. Come on, f of 2 plus h is value of the function at 2 plus h, that is 2 plus h square and so on. F of 2, value of, don't say f common. Have I read this as f into 2 plus h? No. So this is absurd. Tell me what is f of 2? 2 square minus 3 into 2 plus 1. So f of 2 comes out to be minus 1. Okay. We need f of 2 plus h also. So this is 2 plus h bracket square minus 3 times 2 plus h plus 1. Now you have to simplify this. Type your answer in chat box. Everybody should do this. No spoon feeding. Type your answer in chat box. I know you cannot write h square, but you can at least say h square 2. I think you should get h square plus h minus 1. Is this correct? Please type your answer in chat box. H square plus h minus 1. Okay. Now, what is asked? So, we are asked to find f of 2 plus h minus f2 upon 3. I will substitute the values. H square plus h minus 1 minus f2. So minus 1, actually denominator should be, it should be 3. If it is not, change it to change 3 to h. There is no point in writing 3 in the denominator. Otherwise they would not have given h not equal to 0. Make the correction if required. So h square plus h minus 1 plus 1 upon h. So what remains is h square plus h upon h. I hope you won't cancel h directly. Cancelling means division. So take h common and then cancel. Now why can we cancel h? Because it is given that h not equal to 0. So what remains is h plus 1. I hope this is clear to you. So denominator should be h. I'm sorry, it is not 3. It is h. Question 5. Find x if g of x equal to 0. First 3 are simple. G of x, 5x minus 6 by 7, equate that with 0. So 5x equal to 6. So what is x? 6 by 5. Second, g of x equal to 0 means 18 minus 2x square upon 7, 0. So that gives me x square equal to 9. So x equal to plus minus 3. Simple. Third one, g of x, 6x square plus x minus 2 is 0. What are the factors? 3x plus 2, 2x minus 1. Actually, I have omitted one step. It is better if you write that. 3x plus 2 equal to 0. So x is minus 2 by 3. And 2x minus 1 equal to 0. That is x equal to 1 by 2. Now, we will depart so that we will do D part in the next lecture. Bye-bye.